Question number 1. A company needs to design a cylindrical can that holds 475 cubic centimeters of fluid. What are the dimensions of the can that would require the least amount of material? We must identify the variables. Since the question asks for the dimensions of the cylindrical can, the two variables are radius and height, so we label as R and H. Next, to get the least amount of material used, we have to minimize the surface area of the can. The formula for surface area of cylinder is S equal to 2 pi r square plus 2 pi rh. This is the objective function and also the first equation. The right side of the equation involves two variables. We need to get a function of a single variable. It can be done by using the information of the volume of the can. The formula of the volume of the can is V equal to pi r square h equal to 475, which is given in the question. So this is the constraint. Next, we get h equal to 475 over pi r square. Then we substitute 2 into equation 1. So we get s equal to 2 pi r square as 950 over r. Next, we use calculus to find the maximum or minimum value of the objective function. To minimize s, we need to take the derivative of s by using ds over dr. So we differentiate and we get 4 pi r minus 950 r power of negative 2. And then we solve the equation ds over dr equal to 0 to find the critical value. We will get the critical value r approximately to 4.2283. We can use the first derivative test to determine if each critical value is a maximum, minimum, or neither. So r is a minimum because the derivative changes from negative to 0 to positive. And then we substitute r equal to 4.2283 into equation 2, which is h, and we will get h equal to 8.4569. And thus, the dimensions that will minimize the material use are when the radius of the can is r equal to 4.2283 centimeters and height of the can is h equal to 8.4569 centimeters. And lastly, we could also use the second derivative test. So d square s over dr square will get 4 pi plus 1900 over r cubed. It is bigger than 0. Notice that for positive r, the second derivative is always positive.
Now I'm going to explain about question number 4. An airline policy states that all baggage must be box-shaped with a sum of the length, width, and height not exceeding 120 inches. What are the dimensions and volume of a square base box with the greatest volume under this condition? Here I illustrate the box with the height, width, and length. So I represent the height, width, and length with the variables. The h with y, w and l with x. Okay, from the question here, a sum of the length, width, and height is not exceeding 120 inches. Mathematically, we can write it like this. L plus w plus h is equal to 120. So by using the variables, we got 2x plus y equal to 120, and I represent this equation is equation 1. And then from the question, they want the volume. So the formula of the volume is length multiplied by width multiplied by height. So we got here is v equal to x squared y, and I represent this equation is equation 2. And then from equation 1, I rearrange the equation then so that we can use the equation and we can sub into the equation 2. Okay, after the rearrangement of the equation 1, we got here y equal to 120 minus 2x. And then this equation will sub into equation 2. And we got here is vx equal to x squared bracket 120 minus 2x. And after we multiply, we got 120x squared minus 2x cubed. Okay, if you want to arrange the equation following the power, and we got this negative 2x cubed plus 120x squared. And then after that, we want to know what is the x value. We derive the volume become v prime x equal to negative 6x squared plus 220x. And then we equal the equation with 0, and if we look at here, there is two possibilities of the x value. There's the x value, either the x value is x equal to 0 or x equal to 40, and we only choose x equal to 40 because if we can see here, x equal to 0 is rejected because x value is impossible to be 0. As you can see here, what is x? X is w, width and length. So it is impossible for those to be 0. So the accepted value is x equal to 40. So after we know what is the x value, we want to know either the x value is maximum or minimum. So we use the first derivative test, and then we construct a table. It has interval, f prime x, behavior, and the shape. So 40 here is the outliers because if we substitute 40 into here, it will we will get 0. So the interval here is negative infinity until 40 and also 40 until infinity, and it is the open interval, is not closed because we cannot include 40. So you can choose any numbers below 40, and I choose is 38, and you can see here the value here is 456, which means it is greater than 0. So it is positive value, it's concave up, and this is the shape. Okay, and then we can choose any value above than 40, and I choose here is 45, and the answer here is negative 1350, which means is below than 0. So it is concave down, negative value, and the shape is like here. Okay, if you want to determine if the x equal to 40 is maximum or minimum, is we can combine both shape. Okay, we can right here the shape is concave up and then it's concave down. So we can determine here it is maximum value. Okay, and then we're gonna find the y value by using the equation above. So y equal to 120 minus 2x. So we substitute the x value here, and then we got 40. And then from the question, they want the volume. So we can substitute the x and y value into the volume equation, v equal to x squared y, and we got here 64,000 inches cubed. So we can conclude that the dimension that will produce the largest area are with the length 40 inches, width 40 inches, and height 40 inches, and the volume of the box obtained is 64,000 inches cubed.
For question 7, at which points on the curve y equal to 1 plus 40x to the power of 3 minus 3x to the power of 5 does the tangent line have the largest loop? Firstly, we have to maximize and take the derivative. Y prime the x to the power of 2 minus 15x to the power of 4. And then we differentiate again, we got 240x minus 60x to the power of 3. After we got the equation, we use it to find x. And then we got x equal to plus minus 2. After we got the x, we should find y. We find y with using the equation that we got x equal to plus minus 2. After we got the x, we should find y. We find y with using the equation that they given in the question. And then we got y equal to 2 to 5 and y equal to negative 2 to 3. Lastly, we got the points that maximize the tangent line slope are 2, 2 to 5 and negative 2, negative 2 to 3.
Hi, Assalamualaikum. My name is Mohammad Zailan Rashid. My matrix number is 207961. Okay, today I'm going to explain question 10. So question 10 is, a boat in the ocean is 3 miles from the nearest point on a straight shoreline. That point is 5 miles from a restaurant on the shore. A person plans to row a boat to a point P on the shore and then walk along the shore to the restaurant. If the person walks at 4 miles per hour and rows at 3 miles per hour, at which point on the shore should the person land to minimize the total travel time? First, we define the variable used in the problem and organize the information using a picture. So we need to draw the diagram first because it can make us more easier to solve the problem. Okay, so from the diagram that we draw, we get walking distance is equals to 5 minus x, and rowing distance is equals to z. Next, we list the constraints. Walks is equals to 4 miles per hour, and row is equals to 3 miles per hour. Okay, the question asks us to find the total travel time need to be minimized. So total travel time need to be minimized is equals to time is equals to distance over rate. T is equals to D over rate. Okay, next we create the equation to find Z, and we get Z is equals to square root x squared plus 9. So we know that time total is equals to T walk plus T row is equals to D walk over R walk plus D row over R row. Okay, T is equals to and then we just put the value into the equation, and we get T is equals to 5 minus x over 4 plus square root square x squared plus 9 over 3. And then, okay, next step. Okay, next step, we use calculus to find the maximum or minimum value of the objective function. So we need to use derivatives use first derivative to find x, and then we get s is equals to 9 square root 7 over square root 7. Okay, after that, we use the first derivative test to determine if each critical value is a maximum, minimum, or neither. So we know that x is equals to square root 7 over square root 7 is a minimum because the derivative changes from negative to 0 to positive. And then what we need to do is to put the value of x into the equation, and we solve the equation, and we get t is equals to 1.91. So the least amount of time it will take to reach the restaurant is 1.91 hours. Okay, that's all for me. Thank you.